Yes, of course.
So, hello and welcome to 7th week live session. So, uh, let us start with the first question. Just a moment. Yeah. So, mass of nucleon, lambda baryon, and sigma baryon are given to us. We have to find the mass of cascade using the Gelman-Okubo mass formula. Okay. So the formula is following. Three m lambda plus m sigma divided by 4. You just have to use this, substitute all the given values and obtain m of cascade. So that will be equal to 3m lambda plus divided by 2 minus mn sorry, this is a typo, this should be MEV. So this will be in the unit of MEV by C square, and you will obtain 1294 MEV per C square. Okay. Tell me answer to this question on chat box. In the electron nuclear scattering, the differential cross section is written as this, where d sigma d omega Rutherford is the Rutherford scattering cross section. What is FQ square? Is it a correction factor to indicate that nucleus is not a point particle? Is it a correction factor to include effect of nuclear spin, or a correction factor showing relativistic effects of the scattered electron, or is it a correction factor to include spin-spin interaction of the electrons and nucleus? Which option is correct? None of you have watched the lecture? Okay. Yeah. What about others? Okay. Yes, this is the correct option. It is a correction factor to indicate that nucleus is not a point particle. The third question is also similar, related to that. Mott scattering formula for electron nucleus is written in terms of Rutherford scattering formula as this, where V is the speed of electron and C is speed of light in vacuum. The correction factor takes care of, so this correction factor takes care of spin-spin interaction of the electron and nucleus, the relativistic effect, or the fact that nucleus is not a point particle, the spread of the electron beam. The correct option would be no. it is not the spin-spin interaction of electron and nucleus. For that, there was some other factor like A option is not correct. This is basically takes care of relativistic effect. So when V is close to C, that is velocity of the electron is close to C, this factor becomes cos square theta by 2. Okay, so this correction factor basically takes care of relativistic effect, and these are also incorrect. Okay, the resonance scattering process indicates the proton is a point particle, that proton has electric charge, that there is structure within the proton, and that electron is relativistic. So which option is correct here? Well, the correct option is proton has structure. Proton is not a point particle. So by structure we mean it is made up of 3 quarks. So this delta plus we know has mass greater than proton. So this is possible because proton has structure. So the quarks within the proton actually reconfigure itself in such a way that it gives rise to a new state, which is excited state compared to the proton. So okay, so C option is correct here, these 3 are incorrect. So basically proton takes the energy of this electron and goes to this higher energy state or excited state. So it can also happen that so this is proton, so it has charge +1. You know that proton has UUD quark content, and the quark content of delta plus is also UUD. So they share the same quark content, but the question, if you look at carefully, it is just given that delta star, so it can also be delta plus. It can either be delta plus, then the final state product will be electron, proton and pi 0. Suppose if it is delta, it can also be delta plus plus, then the final state would be electron, proton and pi plus. Okay, so basically what happens is that the quarks within that proton can also take some of the angular momentum of the incoming electron, okay, and give rise to different quark content. So delta plus has UUU, right? So the quark content of delta double plus has quark content UUU, so it is different from the quark content of P, but it can also be delta double plus and not just delta plus. So that's why question is just given as delta star. And the charge of pion is also not mentioned, so it will be according to the excited state delta star, the charge of pion. Okay, so yeah, so the proton takes some of the energy of the incoming electron and goes to an excited state, and sometimes sometimes it can also observe the angular momentum of the electron. And give rise to a different spin state. And all these are possible because the proton is not a point particle, but is made up of quarks, which can reconfigure itself to give rise to okay. So what is the isospin value of pion? Last time we drew the
I have one doubt. Can I ask?
yeah.
Now in this previous example, this delta particle has a higher mass than the proton.
Yeah.
So it is around 200 electron volt higher than this. So even for that moment, for the conservation will be for is it from the kinetic energy that it will of electron that it will have, how that conservation of energy will be followed in that case.
So see, this is an intermediate particle, like it immediately decays to proton and pion. So this will happen for a very short amount of time.
Even for that short period of time, can we say that conservation of energy will be not followed for that moment I am asking?
Okay, so you are saying the mass of delta star is greater than the mass of proton. So how
Exactly.
will it conserve energy?
Exactly.
Well, I think it is happening because reconfiguration of the quark content of the proton. But energy conservation that you are saying, I think for the intermediate particles we don't have to care about that.
Okay, thank you.
So okay, so the what is the isospin value of pi plus? Can you recall from the last assignments? Sorry, did you answer this? Yeah?
C.
Yeah, so yeah.
It is plus 1.
Yeah. Isospin of pion is one, and for pi plus the third component is plus 1. And pi 0 it is 0, and pi minus it is minus 1. So whoever wrote 0, it is for pi 0, okay, not for pi plus. And what is the quark content of delta 0? Do you remember the decouplet?
UDT.
Yes. Should I draw the decouplet again?
It is there with us, man. We have done it last time.
Yeah, last time. Okay. So yeah, most of the questions are like MCQ type, this assignment. Okay, select the correct statement regarding the K mesons, K plus and K0. So what is the quark content of K plus?
US bar.
And K0?
DS bar.
Yeah, so do they have same strangeness?
Strangeness.
What is the strangeness of K plus?
It's plus 1.
Is it? Yeah, and for K0 also it is plus 1 because both are having S bar in it. So A option is then correct. What about hypercharge? What is the formula of hypercharge? Do you know? From the lectures?
Strangeness plus baryon number. Y is equal to S plus B.
Yeah, baryon number plus strangeness plus what else? There were 3 more quantities, I think, also. Baryon number plus strangeness plus charmness plus bottomness plus topness. So yeah, none of these will matter to us for this question, but okay, so that is the hypercharge. So hypercharge for both K plus and K0 will then be, what will be the hypercharge for them? So baryon number is for K0 and K plus, baryon, what is baryon number? What is the baryon number of any meson?
0.
Yeah, so baryon number 0.
0.
And strangeness is plus 1 and all others are 0. So hypercharge for K plus as well as for K0 will be plus 1. Okay, because yeah, so B option is also correct. They have the same isospin but differs in the third component by 1 unit. Is that correct? What is the isospin of K meson?
Half.
Yeah, isospin is half for K1, and for K plus I3 is what is the I3 value for K plus and K0?
I3 value for K plus is also half.
And K0?
So minus 1 by 2.
Sorry. Yeah. So then C option is correct or not? It says they have the same isospin but differs in the third component by 1 unit. Is this correct? C option?
Yes, it is correct.
And D option is saying they have the same spin. Well, spin of K plus and K0 both are 0, normal spin.
Yes, yes, they have same spin.
Sorry?
They have same spin.
I couldn't hear you. Okay. So 6 observed hadrons have these quantum numbers. We have to identify their quark constituents. So you have the chart with you, the different quantum numbers, but since we need it here, let me just redraw it quickly. So quantum numbers are given to you, you have to construct the hadron. So by hadron it can either be a baryon or a meson. So if it is a baryon, it will be made up of 3 quarks. If it is a meson, it will be made up of 1 quark and 1 antiquark. Right? So, okay. By B I am denoting baryon and B prime I am denoting bottomness. Strangeness. Topness. Okay, and we also need the charge. So baryon number 1/3 for all. Strangeness is -1 for S. 0. Charmness is 1. Okay. 0 for others. Bottomness for bottom quark is top, bottom, I think, yeah. So this is bottomness will be -1, 0, 0, 0, +1. Okay. So see. So you tell me what will be the quark content for this. Q is 1, baryon number is 1, strangeness is 0, charmness 1, bottomness is 0. So what does it mean? So it is a baryon, so it will be made up of 3 quarks. There is no s quark, there is 1 charm quark and no bottom quark. So this much is clear to us that there will be one charm quark, right? Because charmness for a charm quark is +1. So charmness is 1. Now the what is the charge for charm quark? It is 2/3. Right? So what will be the other two quarks? It cannot be S quark, and it cannot be B quark as well. So the two other quarks has to be either D quark, both D, or both U, or one U, one D. Which particular configuration will be the possibility for Q to be 2 ultimately? Can you understand the question?
Please go through it again.
Yeah, so
Both will be UU, I think.
yeah, exactly. So so see, all the quantum numbers are given to you. You have to just construct the quark content looking at these quantum numbers. So you know the quantum number for all the quarks. If it is, suppose here it is so here baryon number is 1, so second element is the baryon number. So it means it will be made up of 3 quarks. See, the charmness is 1, and you know for one charm quark the charmness is 1. So you already know that charm quark will definitely be one of the quarks. And you also know it is a baryon, so there will be 2 more quarks, and you can also see that charge of the baryon will be +2, and there will not be any S quark, there will not be any bottom quark. So that means in order to have charge 2, so charge of C charm quark is +2/3, and total charge is 2. So you need to have Q prime such that charge of charm quark will be such that charge of charm quark plus that Q prime, whatever the quark you will have here, will have total charge 2. So 2 minus 2/3, if we do, we get 4/3. So in order to have 4/3 charge, you must have 2 other U quarks. So the quark content will be then UUC. Is this clear?
Yes, ma'am.
Yes.
Okay. Okay. So then tell me the next one. So it is again baryon, but its total charge is 0, and strangeness -2, charmness 1. So what will be the quark content? What can you tell me about if charmness is 1, then there will be one charm quark, right? Just as the previous case. Now strangeness is -2. What does that mean? How many S quarks will there be?
two strange and one this charm.
Exactly. Now you can also verify whether the charge is becoming 0 or not. So both the strange quarks are having charge minus 1/3, and there is one charm quark, so plus 2/3, that is 0, and it is also a baryon, and there is no bottom quark. So all the quantum numbers are being satisfied. So the quark content is 2s and 1c. Okay. If it is 0 0 1 0 minus 1, then now you can see it is not a baryon, and question is saying all the quantum numbers are given for hadrons, so that means it has to be a meson, right? So there will be one quark and one anti-quark. Can you tell me what is the quark and what is the anti-quark? So strangeness is 1, so what does that mean? And bottomness is minus 1.
BL as well.
Yes. Okay. Let's do the other 3 also. Strange charm, bottomness. This one is 0 minus 1 1 0 0. So now baryon number is minus 1, strangeness is 1, and charmness 0, bottomness 0, so no charm quark, no bottom quark. And baryon number minus 1 means it will be made up of 3 anti-quarks, and strangeness is 1, which means, so you tell me the quark content now. There will be 3 anti-quarks and total charge has to be 0. So strangeness is 1, so that means there will be one S bar, and what about the other 2 quarks? So you cannot have any more S bar, you cannot have any C bar as well as B bar, so you have to bring in U and D. But to have baryon minus 1, you can either have U bar or D bar or U bar D bar. So which particular combination when added to S bar will give you charge 0? That's what you have to think, right? So S bar charge is 1/3. So total.
It has to be what you are, no ma'am?
Yeah, exactly. Okay, let's do the last two. 0 1 minus 1 1. Yeah, now it is a baryon again. Total charge 0, strangeness minus 1, charmness 1. Can you tell me the quark content for this case?
D, ma'am.
Sorry?
DSC.
DSC. Okay, let's check the charge. So it is a baryon. It has strangeness -1, charmness is +1, and total charge will be -1/3, -1/3 plus 2/3, so 0. Yeah, so this is the correct quark content. The last one is -1 1. So again a baryon, total charge -1 and strangeness -3. No charm quark, no bottom quark.
All will be yes.
Yes. Yeah. So yeah. So okay. Now these questions also I would request you to answer. Examine whether the following decay processes are allowed or not. So you tell me. Will it be allowed? And if not allowed, then which particular thing is being violated? Is it baryon number, lepton number, or charge? Okay, or because of energetic reason. So we know mass of mu minus is greater than the mass of electron, and yeah, this has 0 mass. So mu minus, so this is not, I mean, for energetic reasons it is allowed. But what else do you need to check whether it is allowed or not?
Lepton.
Lepton number you want to check. Okay, so what but okay, so what is the lepton number for mu minus?
-1.
Is it -1 or +1?
-1.
I think it's +1, right? Let me. Oh God.
The last lecture you have given us the chart.
Yes. So from there, I thought you were reading, but it's not -1. That's why I thought of redrawing it.
Yeah, you are correct, ma'am. Sorry.
Yeah. Okay. Anyway, I just.
I was looking at the chart. Sorry.
Okay. I understand. Yeah. So all the lepton numbers for all these will be, but there are different lepton numbers. Electron lepton number, muon lepton number, and tau lepton number. Okay, so then you want to do lepton number. You want to see whether the lepton number is conserved or not. So is it conserved?
No, the left hand side we have this muonic lepton, the right side we have electron.
So okay, so let us first check electron lepton number. On the left hand side it's 0 because it's mu1. On the right hand side it's 1, and for this it is -1. So total lepton number on the right hand side is 0. So electron lepton number is conserved. right?
Yes, ma'am.
So what do you have to check then?
Mu1 electron number.
Yeah. So mu1 electron number on the left hand side is 1 and on the right hand side is 0. So that means mu1 electron number is not conserved and hence the process is not allowed. Okay. Okay. So yeah, just let me write down that. Okay, what about the next process? Just electron, sorry, plus proton. Is it allowed or not? Okay, one by one. So energetic conditions are being satisfied. On the left hand side we have proton, which is much heavier compared to pi 0. So we need to check then lepton number. But now on the left hand side, also on the right hand side, we just have electron lepton number. So it's 1 on the left hand side, and for proton it's 0, of course, that's the baryon, and for electron neutrino it's again 1 and 0 for pi 0. So electron lepton number is conserved. So so is the decay allowed?
Conservation of baryon number has to be checked.
Okay. So what is the baryon number for electron?
0.
For proton?
1.
Electron neutrino?
0.
And pi 0?
0 now. It is 1 up and 1 until.
Yeah. So then baryon number is?
Not conserved.
Exactly. So then the decay is not allowed. Third one, proton decaying to positron plus photon. So here, just by looking at it, you can see that on the left hand side there is no lepton number. So lepton number is also violated, as well as baryon number will also be violated, because on the left hand side you are having proton. So this is again not allowed. Lepton number as well as baryon number is violated. Not allowed. What about the last one? Cascade 0 decaying to proton plus pi minus. Yeah. So you tell me whether it is allowed or not. Charge is conserved. So none of these are leptons, right? What about the baryon number? What is the baryon number for casket 0?
One.
Yeah. So for proton also 1, and it is a meson. Charge is conserved. 0, 1, minus 1, and mass of cascade is much higher compared to proton. So that means this process is allowed, right? Okay, I think there is no doubt. These like the last question, similar to the last question, we solved many problems in the earlier assignment. Okay, so yeah, let me know if you have any doubt. Otherwise, we are done with this assignment.
Well, there is one question, but that doesn't belong to this assignment. I mean, this question that you are discussing. Can I ask that?
Which one?
I mean, in the previous assignment, there was first question about number of reaction was given to us, and it was asked which of doesn't belong to this electromagnetic interaction, or I mean, which of these experiments will not be influenced by electromagnetic interaction. I have got the answer, but I need the explanation. In answer, means after this assignment, they give just the option, which are the correct option. But can you provide the explanation for that?
I'm not on the same page. Like, you are asking the assignment that you needed to solve for the course, right? Not the assignment that we discussed.
Right, exactly, ma'am, exactly.
Okay. So what was the question, and then what was your, like, what is your query? Can you just tell me again? I couldn't follow you.
Just hold on, I will open that assignment.
Yeah. I will stop sharing them.
Yeah, I think that was the question number 1 of assignment number 6.
Yeah, exactly.
Which one of the following interactions are not influenced by electromagnetic interactions?
Yes, sir, yes.
Yeah, I was having the same question and I asked the professor, Babu sir. So he incited the certain things, but he then said we will discuss it in next interactive session. That will be good, madam, if you will discuss that here also.
Yeah, just show me the question. Which question you are saying? I'm still not. Are you sharing the screen? I thought you will be sharing the screen.
Yes, now I have opened the assignment. I will try to share.
Okay. I hope you will be able to, or do I have to give permission? Okay, yeah, it's being shared.
Can you see the first question, ma'am?
Yeah. Which of the following interactions are not influenced by electromagnetic interactions?
Electromagnetic interaction के लिए you need this charge to be there, right? Ma'am?
You need photon.
Charging photon.
Yeah. which of the following interactions are not influenced by electromagnetic interaction? So the correct option would be the first one, and also
And the last one.
Last one.
Yeah.
I was sure
Can you-
with the first
can you-
one, that's why I marked it, but I got that next second one I just wrong.
I can see gamma photon only for the third option.
Yeah, ma'am.
What about the second option? Second option on the right hand side, it is mu plus, and what else? Mu
Mu
minus.
Basically, mu takes part in both interactions. It takes part in weak interactions as well as the EM interactions.
Exactly.
That's why.
I marked it, but I got it wrong now.
Leptons only do not take part in strong interaction. Otherwise, leptons do take part in weak interaction and electromagnetic interaction.
But they have put it, I mean, they have not taken it as option, correct option.
I feel like B should also be correct, and yeah, last option is also correct because it is not having any gamma photon.
Exactly, ma'am. Yeah, I was also sure about the fourth one.
Someone else was commenting on mu plus mu minus point. Sorry, the option. What do you say?
Namath said mu can take part in both interactions, EM interactions as well as weak interactions.
Yeah, true. Leptons only do not take part in strong interaction. Leptons do
Strong
take part
interaction,
in electromagnetic interaction as well as because they are having charge. Okay, I will make sure of it and then discuss in the next class.
Acha, one more question is there, ma'am.
You have more
Suppose that,
doubts.
ma'am, yeah, ma'am, suppose we have a gamma transition, and after solving this, if suppose we have this option for E2 and M1. Again, I am repeating E2 and M1. So, as per this lower angular momentum rule, we will go for M1. But in comparison to magnetic and electric, we go for electric one. So, which this option will be correct? Whether to choose M1 or E2?
If I remember correctly, magnetic interactions are less probable. Show me the question again.
It is
You are saying you are having M1 as well as E1.
M1 and E2. If suppose we are getting after solving that string parity,
Okay.
if we are getting E2 and M1, so what option we should select? Because we have learned in the lecture that suppose we have same this electric and magnetic type, then go for the lowest angular momentum, and for electric and magnetic both options are there.
Yeah.
Then my confusion is that should we go for M1 or E2? Because M is having the lowest L.
Yes.
And E is having this one number higher. So should we go for E2 or M1?
I think for if it is same angular momentum, then only E dominates. Otherwise, you always have to choose the less angular momentum.
Got it there. Got it.
Yeah.
Thank you. Thank you.
Okay. But I think as I can see on my notes, there was a question where the possible transitions were M1 and like E1 and M2 both were not satisfying the conditions, like the parity conditions. So the possible transitions were M1 and E2, and
Exactly.
if you have to choose among these, like for that question, we wrote both the transitions are possible, like M1 and E2. But you have to, if you have to choose any one among these, then I think M1 should be the correct option.
Got it, ma'am.
Okay. Any other doubts?
No, ma'am.
Okay then. Yeah.
Thanks a lot, ma'am.
Yeah. Okay. Okay, let's meet next week then.